Hello, this video is for learning intention number 28, and here we're looking at conditional probability. And this I find a very tough topic. Conditional probability is, the maths is understood, the philosophy isn't. And if you're actually interested in understanding what's going on with conditional probability in your own time, look up something called Bayes' theorem. Look up Bayes' theorem if you really want to understand what's happening here. But if you don't have time, which I doubt you do, you busy people, just make sure you get the formula and the method down. If you're interested, Google Bayes' theorem, because it's a very conceptual area. I find it quite challenging. Alright, what's this about? So conditional probability is when we're given some information. It's when we're given some information and it kind of changes the odds. So conditional probability, it's when we're given something, given some information. And it changes the probability of the answer. So let's start with, as usual, because we've got the deck of cards, I'll do an example the old-fashioned way, and then we'll look at it with the formula. So what's the probability of selecting let's say, what's the probability of selecting a heart at random, given, and remember this line means given, that we know the card is red? What's the probability of getting a heart at random, given that we know that the card's red? Well, we know that increases the probability because we know that a heart is a red card, so we know that it's going to be higher than what we'd usually expect. Well, how do we answer this? Well, the old-fashioned way is to look at the sample space. Now, we've been given some information. We know it's red. So we can look at our sample space and say, well, we can cross out all this stuff because we know it can't be any of those. We know it has to be a red card. We've been given some information. We've been told it's red. So we know it has to come from here. What's the probability of it being a heart? Well, let's circle all the hearts. The probability of it being a heart is 13 out of, now there are only 26 possibilities. Before there were 52, but because we've been given some information, it's out of 26 now. And that simplifies to a half. Well, okay, that's all well and good. What's this formula we need to know? This is the formula. If you have time, please do some more reading. Please try to understand where this comes from. If you don't, just memorize it. The formula is the probability of A given B equals the probability of A intersection B over the probability of B, and we can't divide by 0, so we have to say the probability of B does not equal 0. So we just have to put that there because we can't divide by 0. This is the conditional probability formula. So this is the formula we use when we've been given some information. Let's try to use this formula to answer this question. Alright, so we need the probability of a heart and a red card. So where do those intersect? Well, these are all the red cards. These are all the hearts. So the probability of drawing a card that's both a heart and red, well, it's just the probability of drawing a heart, isn't it? So it's 13 out of 52, which equals a quarter. Alright, what's the probability of drawing a red card? So that's the probability of B. So I've worked out the probability of A intersection B. What's the probability of B, which in this case is drawing a red card? Well, we know that's a half. That's all well and good. Let's use this formula. So the probability of heart given a red card is going to equal the probability of a heart and a red card divided by the probability of selecting a red card. Let's sub in our numbers. So we've got a quarter divided by a half. Well, you can use the algebraic method you like, but a quarter divided by a half turns out to be a half. Solve that how you want. It's going to give you a half. So the way I did it was using that trick where it kind of flips around this line, so you get 2 quarters, which gives you a half. That's one way to think about it, but the answer's a half. And that works. Well, that's good. Let's look at another example. And let's use the formula this time. So, what's the probability of drawing a jack given that we know it's a face card? We'll use F for face card. Well, that's going to equal the probability, and I'm using this formula, of drawing a jack and a face card over the probability of drawing a face card. So the probability of drawing a card that's a jack and a face card, well, these are the face cards here, and drawing a jack, well, it's automatically a face card. So that's 1 out of 13. Over the probability of drawing a face card is, well, these are all the face cards. So you've got 3 by 4, which gives you 12 out of 52. And you can simplify 12 out of 52 to 3 on 13. 1/13 divided by 3/13, that works out to be 1/3. And that makes sense, doesn't it? The probability of drawing a jack, given that you know it's a face card, because if you look over here, if you reduce your sample space to this, and you want to know the probability of getting one of these, that's a third. That's 1/3 right there, so you can almost see it. You can see conditional probability working. If you want to know more, Google Bayes' theorem, it's fascinating stuff. At the very least, you must memorize this formula and how to use it. And if you have been, thank you for